Hi Geometry, this is lesson 11 of Unit 5 on page 589 of our workbook. And we're going to start discussing volume and calculating volume. And when you calculate volume using the volume formulas that we're going to be learning, you usually need to know that, well, we always need to know the height of our object. So sometimes the actual height isn't given to us. So for example, take a look at A on this page. This 17.3 is not the height of my cone. The height of my cone is this perpendicular height from the top or the vertex to its base. I want to know this. This is the actual height. This is actually called the slant height, and we've mentioned before it does have a use later on. It's what we're going to use to help me calculate surface area of an object, but not the volume of the object. So in these two examples, we're supposed to find the height of each solid. So I want to remind you today of some things that we know, such as the Pythagorean theorem. In this picture, my slant height is the same on both sides of my cone. And if I want to calculate my height, which is unknown, I could use the fact that the height and my radius and my slant height make a right angle, a right triangle. And I could use the Pythagorean theorem then to calculate my missing height. So remember your hypotenuse, when you fill in your a squared plus b squared equals c squared, your hypotenuse is always across from the right angle. So in this case, that would be my 17.3 slant height. So this is my 17.3, this is my slant height. My radius then and my height are my a and b. Doesn't matter what order you put them in. So 6.5 squared plus h squared is what we'll call my height. We'll call it h. So to do my calculations, I would square 6.5, I would subtract it over. H squared, once you do your math correctly, should be 257.04. Let's take the square root of both sides, and we should get 16.03. Make sure you can do that on your own. Pause this video if you need to. So what about this diagram on the right? So in B, the 12 millimeters, again, is this slanted height. It is not the height from my top base to my bottom base. That is really the height, if you will, from my top base to where my bottom base is. This is the actual height, wherever you want to visualize it. That blue distance, h, is actually the actual height of this oblique. Remember our vocabulary. This is an oblique cylinder. So let's calculate that. Unlike A, I don't have enough information to use the Pythagorean theorem. However, I have enough information to use trig. Remember that this height and the plane that my base is on always makes a right angle. So off to the side here, this little figure right here is a right triangle with a 50-degree angle. And so I could use it to calculate my height using trig. This would be my hypotenuse for my 50-degree angle. This is my opposite side, and this is my adjacent side. However, my adjacent side doesn't have any measurements written there. I'm not trying to find it, so I'm not actually going to use it in my calculation. Remembering my SO, CA, TOA, I know that opposite and hypotenuse is a sine problem. So I'm going to set up a sine equation with this 50-degree angle. So sine of 50 equals opposite over hypotenuse. And so in this case, I'm going to multiply my 12 over. And I'm going to find that my height then is approximately 9.919 millimeters, I believe is what my measurements are. And over here it was inches. Sorry about that. So that's how I can calculate my height. Keep in mind, in our volume problems, in both of these problems, you'd have to continue on to calculate your volume. So we're going to look at these solids over a couple class periods. I'm going to put answers only for the volume of each one on this page. So you can jot these down, and then at your leisure, if you're not in class, try to calculate the volume of each. Couple are easy, couple are medium. There's a couple that are kind of hard. and see which ones you might have questions on for office hours, for instance. But for today's video, you're going to take a look at A, we're going to take a look at B, we're also going to take a look at C. And then the other problems we'll be looking at in our Zoom class, or if you missed that class, you can come to office hours. So taking a look at the first one, I want you to visualize what this is. Remember, our volume is the area of the base times the height. So in this problem, for this prism, my base area is a triangle. So the volume of the base area of a triangle is 1/2 the triangle's base times height. Keep in mind that first H is for my blue triangle on the bottom, times then the height of my whole prism, which is 8. So I'm going to go ahead and put an 8 there so we're not confused by two H's. So my triangle's area, my base and height have to be perpendicular to each other. So this 5 and this 11 are the base and height of that particular triangle. Unlike D, take a look at D, you guys. When you get to D, when we do D, we are actually missing this side right here that's perpendicular to the 7. Before we can calculate the volume, we're going to need to calculate that missing blue side. Coming back to A, so all the numbers I need are here. My volume is 1/2. My triangle's base, we'll call it the 11, although it doesn't really matter. The triangle's height, we'll call it the 5. And then my height of my entire stack of triangles is 8 centimeters tall. So multiplication's commutative. You can really do it in any order. If I was doing this without a calculator, for instance, I might take the 1/2 times 8 since it's even and get a 4. 4 times 5 is 20, and then 20 times the 11 to get my 220 centimeters cubed. If you're working on a calculator, I would just start in with 0.5 times 11 times 5 times 8. However, whatever order you multiply these four numbers in, you're going to get 220 centimeters cubed. So let's take a look at B. B reminds me of the problem we did on the front side, because this 10 that you see in the problem is really your slant height. It is not the height of my oblique cylinder. So this was a triangular prism that we just did. Let's write some names here. Triangular prism. And this is an oblique cylinder. So this oblique cylinder, I need to find my base area and I need to find my height. So my height of this, I'm going to calculate with trig again. I know this is a 10. I'm going to not really write it right there. It's just in a bad spot. So this is a triangle with a hypotenuse of 10, because this is my right angle, and a 40-degree angle right here. So my 40-degree angle. Remember your volume. I need some space to write, so if it's okay with you, I'm going to do in this video, I'm going to do my calculations for B right here at the bottom of the page. Volume of my cylinder is my base area times my height. For a cylinder, the base is a circle. So we say it's pi r squared h. So in this problem, my r is 5, because I can see clearly my 5 starts in the center and goes to an edge. So that's definitely my radius, not a diameter. Notice in E, you have a radius of 20. Notice in G, it's the circumference, the distance around. So when we do that one, we are going to have to figure out the radius from the circumference before we can keep going with that problem. Coming back to B, however, my volume then is pi times my 5 squared times my height, which I need to find. I'm going to do this in red. So for my trig problem, if the 40-degree angle is my angle, then my height is my opposite side, the 10 is my hypotenuse, my adjacent side, I don't need it, I don't know it, it's not useful, I'm not using it. So opposite hypotenuse would be sine. So I'm going to do an off to the side a calculation where my sine of 40 equals my height, which is opposite, over my hypotenuse, which is my slant height of 10. Multiply your 10 over. 10 times the sine of 40 equals the height. When I calculate that, I get approximately 6.43. Keep in mind, this is where your answers and my answers may start to differ. If you said this was 6.4 or 6.42, or if you used all the decimals on your calculator in your calculation, you are going to get a different answer. What do I mean? Well, it depends on the exact number you stick in here, how many decimal places you have, can sometimes change up your final answers to look a little different. So 6.43 times 25 is 160.75. So I guess I'm going to go this way. This is 160.75 pi units cubed. So first of all, that's if I left pi in it. That number again can be slightly different depending on how many decimal places I use for my height. Now, if you'll notice my answer up above doesn't have pi in it. Well, it's the same thing. Let's actually take my 160 times this pi. Use the pi button on your calculator. Don't use 3.14. And I get, on my calculator right now, I'm getting 505.01. You'll say, well, that's not the same answer. Again, a lot of things matter. How many decimal places did I use when I did my original calculation last year to get my blue answer? Did I use 3.14 for pi? Did I use the pi button on my calculator? So as we move forward in this unit, you will have to realize that sometimes our answers can vary just slightly based on the number of decimal places we use in our calculation, which can be different for different people. So I just want you to know, don't automatically think that you did anything wrong. We differed here slightly, but both answers were done with the correct operations. Okay, and lastly, I'm actually not going to do this actual whole calculation with you. Calculate the volume of this right prism. You're given, this is a rectangular prism. It's a right rectangular prism. I don't normally write the word right, although I do write the word oblique. You can calculate this. All the correct numbers are given to you. It should be a really straightforward calculation. Make sure you can do it. We'll be looking at this one in class. This is another triangular prism, but you cannot use the 8. The 8 will give you a wrong answer if you use it to calculate base area, because that's the hypotenuse. It's not the base or the height of that triangle. You cannot use the 8. This problem for E, this is a cylinder. You actually have all the information you need to calculate E to get the correct answer. Keep in mind, I left the pi in my answer. I didn't multiply by pi. If you'd like to do F, you'll notice that on F, I am given this 4, but I don't have this height right here. This problem, I would have to use trig. It's a little similar to D. You've got some math to do before you can calculate the volume of this triangular prism. Let's talk about G. Circumference is pi times the diameter, or sometimes we say it's 2 pi times the radius. I have to use those. I have to set one of those equal to 4. So I can calculate my radius, for instance, and then use that to calculate my volume of this oblique cylinder. So if you miss class when we do one of these problems, you'll want to make sure that you can do it. Come to office hours if you need some help on one of them. Moving forward to this problem right here on page 591 of our book. Let's read about this tower that's pictured in Dubai. It's 306 meters tall, so I know the height of this. It's 306 meters tall. It's made up of identical floors, rotated slightly, so that's what's making it so it's not a right, if you will, a right rectangular prism. It's each level, each cross section is stacked slightly different as it's rotated around. So it creates this shape that's approximately 2 parallelograms put together. There's a circle cut out in the floor plan that goes all the way through the center of this building that has air, circulates air and carries pipes throughout this and wiring through this building. So this is my cross section. If I could look from the air straight down on this one. So if you can imagine, the area of this base, if I don't worry about the circle being cut out, is 57 by 35. 57 by 35. And you might say, well, can I just calculate it like a rectangle? Look at this for a moment. Why would it be possible to calculate the area of this cross section as a rectangle? I hope you notice that if we cut off this little section over here, I can slide it over here, and that would create a rectangle that's 35 by 57. Now keep in mind, I'm not considering the circular cutout right now. So yes, my cross-sectional area is at 1,995 square meters. So then it says, describe how the total volume of the building, this is total, including that core, can be calculated. Well, volume is big B times H. So in this case, I can take that big B I got in number 1, that 1,995 square meters for each floor, and I'm stacking them on top of each other for the entire 306 meters. So this is how I could calculate my total volume. It says, what shape is the core of the building? So the shape is a cylinder. If you think about this circular core, it's a cylinder. Sorry, I believe I spelled that wrong. Put the in there for me. Sorry about that. It says, describe how the volume of the building's core can be calculated, including the measurements that would be used. So this cylinder going through this building, if you can imagine, is 306 meters tall, because that's how tall the building is. And this radius, I can calculate. If you look at this picture up here in number 1, that 17 is a diameter. So 17 divided by 2 is approximately 8.5. So, is 8.5. So I could use the volume of this cylinder is the area of the base times the height. The base is a circle, pi r squared times this height. So it would be pi times this 8.5 squared times the height of 306 meters. So then it says, what percentage of the building's volume is taken up by the core? So to find the percentage, I would need to take the core volume divided by the total volume. So I need to calculate both of those in order to do that calculation. So let's go back to number 2. Let's use number 2. This is my total volume. My total volume of this building is 1,995 meters squared for each cross-sectional area times this height of 306 meters, and I get a total volume of 610,470 meters cubed. That's the whole building. Now the cutout core. So I need to calculate, I'm going to use my numbers from number 4 to calculate the volume of the core. The volume of the core then is this pi times 8.5 squared times my 306. And if I calculate everything, even multiplying by pi, since I'm going to be using it in another calculation, I'm not going to leave it in terms of pi, I get 69,455.90. Again, if you have a different number, make sure you've multiplied by pi, and that's also meters cubed. So to find the percent of the core, I'm going to take the volume of the core, the 69,455.90, divided by the total, 610,470. And when I divide those, I get 0.114. Or if I move my decimal place 2 places to the right, that's 11.4%. So of my total building's volume, that circular core going through the center of it is 11.4% of the whole building's volume. Thank you.